All right, we're back. We're on page 6, note 17. We're going to continue our discussion. We just talked about dr d theta, right? So that's going to tell you position relative or your motion relative to the origin. Are you getting closer? Are you getting farther? But it plays with r. Like you need to know the sign of r and dr d theta to really know what's happening. The next thing we're going to talk about, which we started talking about, is we want to talk about the slope of the tangent line to a polar curve. So your polar curves live in the xy plane, which means every polar point also has an xy coordinate. And if you think about it, we know how to get that, right? So we know that x is r times cosine of theta, and we know that y is r times sine of theta. So actually, if we want to write parametrics for a polar curve, we also know that r is our polar equation. So r is f of theta. Just replace it in that equation there. So our polar parametric, the parametrics for polar are just going to be x is the polar curve times cosine of theta, y is the polar curve times sine of theta, and then you can do whatever you want to do. So actually on GeoGebra, if you go back and look at the previous video, you'll see that the way I graphed the polar curve is I just graphed it using parametrics. That actually on your Inspire used to be the only way to graph in polar. And I always felt like it really, people learned more. There's as technology advances, you lose little things along the way. And one of the things that you kind of lost when they added polar graphing mode is that oh, let's just convert to parametric and go from there, or use a parametric representation. So let's see if we can get dy dx. So we now know that x is going to be f of theta cosine of theta, and y is going to be f of theta sine of theta. Now you might notice that both of these are products, which means it's not going to be super fun to find dy d theta and to find dx d theta, but now we can do it. So now we can talk about the horizontal change, like is dx d theta positive, is dx d theta negative, is dy d theta positive, or are you moving up, is dy d theta negative, are you moving down? So we have dr d theta, we have dy d theta, dx d theta, we're about to get dy dx. That's 4 derivatives that are related to these polar things. So dy dx, we know in general, dy dx is going to be dy, we've been calling it dy dt, but dy d theta, that's a theta, dy d theta over dx d theta. Okay, but now I got to work those out. I'm losing it. Where's it going? All right, dy d theta. So we're going with this. Here we go. So product rule. So it's going to be first derivative of the second, second derivative of the first. Okay, so that's where that came from. And then dx d theta. So x is here. So we're just going to use the product rule again. So it's first derivative of the second, second derivative of the first. So fun little fact, I don't have this memorized. Some people do, and if you look in a textbook, it'll tell you that this is how you calculate the slope of a polar curve. But it's just finding the slope of a parametrically defined thing, and then using the product rule. So why would we bother memorizing that when we know how to do each and every part? And it's easier to do every part than it is to try to recall I don't know, all of this. No way. So just remember to get dy dx. So to get dy dx, convert to parametrics. That's 1, 2. Find dy dx for parametrics. We already know how to do that, so why would we add something else that we need to memorize when we already know how to do it? So we have a dy d theta, dx d theta, dy dx, dr d theta. All of them mean slightly different things, and we have to know what all of them mean. So think about them. there's some little info here. So dx d theta and dy d theta are literally telling you what's happening with x and y. The same way dx dt and dy dt were telling you what's happening for strictly parametrics, regardless of their polar or not. So there are like horizontal tangent lines, there are vertical tangent lines. Horizontal tangent lines means that dy d theta is 0 while dx d theta is not 0. Vertical means dx d theta is 0 while dy d theta is not 0. We can find dy dx just in general. And remember, dr d theta it really has nothing to do with slope of a tangent line. It's really about, are you getting closer to or farther from the origin? But that's in relation to, is r positive or is r negative? So there's a lot of different rates of change with polar. So all right, I'm going to stop this here. I will be back in the next video, and we will actually, well, we're going to talk a little more in general about something, and then we're going to actually do some problems, which will be, I think, really helpful. So see you there.